sheet on a dark substrate. That's been a challenge for most digital printers in the past. And when we saw printers, the first generation of printers capable of doing that, we jumped ship and departed from silk screening, and now we do everything exclusively on our digital flatbed printer. The key advantage that we have, of course, with a fabrication process such as ours is we can print on the parts while they're still flat. So that's a huge cost advantage, meaning we don't need any fixtures. We don't need to deal with the finished part in order to decorate it or in order to get the graphics on there. So CNC machining, digital printing, edge finishing, forming, assembly is the sequence we run through. It's a pretty straightforward sequence, and the key thing that we focus on is we do not allow any fixtures or tools of any kind in our whole process to make sure the setup is minimal. So all we do, we call up the files on the CNC machine, on the digital printer, on the CNC thermal line bender. All the parts permanently reside on our server, and the only setup there is to bring up the file on the respective pieces of equipment. The market that our primary focus is on the enclosure market, because most of our customers, or the customer that we target, typically is an industrial buyer, medical equipment company. We see, of course, a lot of wireless devices, and the dilemma that they typically face is that they don't have sufficient volume to justify the investment in an injection molding tool. They have something that is too custom to be served by an off-the-shelf blank housing. And the third option, and that's where a lot of our customers still are, that leaves them with sheet metal in most cases if you want something custom. So we try to target that void. So you can't have plastic, you can't have all the advantage of plastic in terms of weight savings, in terms of not having to paint, in terms of being able to print in the flat state, but you don't have to invest in the tooling. We can give you the custom that you can't get from an off-the-shelf part, and the aesthetic advantage over a sheet metal housing. So that's the niche that we're targeting. If it's a part over 10,000 pieces a year, injection molding is the way to go. But for the smaller volumes, for the typical releases that we see, 50 to 500 pieces a batch, this is a very economical solution because we're not dealing with any kind of setups. Spoke about materials, primarily ABS, a lot of polycarbonate. In a lot of cases, we substitute polycarbonate with PTG. Same impact resistance, same clarity, a little less heat tolerance, but not much, for the price, about half the price of polycarbonate. We use that a lot. So when the specifications not specifically demand polycarbonate, we often suggest a PTG as an alternative. We have flame retardant grades. That's another question that I often get. We carry an ABS polycarbonate blend that meets UL94 B0, which means it is self-extinguishing.